Testing, testing. 1, 2, 3. Oh, shit. Mute it, unmute it, etc. Good morning, everyone. Good morning, good morning. Seems like the delay is pretty heavy today. Well, what are you going to do? Wow, of 4 concurrent viewers, 3 of them have said good morning in the chat. Come on, you 4th concurrent viewer. I want to see you in the chat. In the chat. In the chat. In the chat. Thank you. Okay. I heard something about there being like an assessment for 1MD or 1DM3 today, like a test or a quiz or a midterm or something. Yeah, there we go. Oh, hey. Someone has my my icon as their icon. Okay. Yeah, I made this myself with my pixel editor. So, anyway. Good morning, Fancy Meat Computers. Welcome once again to Computer Science 1XC3 for those of you who are here. Welcome, welcome, welcome. For those of you who are not concurrent, you guys are welcome as well, if you're watching this at some sort of temporal displacement. So, this is the last class. We're not going to cover anything too difficult in this class, and the slides that I have prepared are not, they are not, shall we say, long enough to fill the entire time slot. So this is what I would like to do with you guys. This is the last class before the exam, so if you guys have any questions about the exam, August the 4th is the 1DM4 quiz, okay, and today is the 3rd, so it's tomorrow, okay. Like, quiz implies a smaller test. Like, is this a small test, or is this, like, I don't know, it's kind of weird, because, like, for summer courses, like, the end of semester cutoff for major assessments before the exam period is kind of like, does it exist? Does it not exist? Who knows? Who cares? My general feeling and experience is that summer courses are subject to somewhat less scrutiny because of the absence of the registrar being involved in the exam scheduling. So, you know, I'm like, yeah, anyway. So today is the last class for this class. The exam is on Saturday. Hopefully that doesn't intersect with any of your other exams. It's a small test but hard. Okay. Well, you know, small but hard is sometimes better than long but easy. But, yeah. Anyway. So the exam is on Saturday, and I thought that we could use the second half of this shindig to go over, to review whatever you guys want to review from the course. Sort of do one of those self-directed review sessions that I'm so famous for. You know, in a normal semester, I would use the last class, which would be an hour, to do that anyway, so using an hour for it here seems appropriate as well. But, yeah, anyway. That's, so if you have any questions about the course in general, or the exam specifically, please hold those until after I've done our lecture material for today, and then we'll get to it. But you also may notice that there's no lab today. That's probably you guys are like, oh, thank goodness there are no more cursed labs. But yeah, anyway. Hopefully, yeah, awesome. Yeah, there is a fair delay today for one reason or another, so, you know, probably at some point the connection will get reset and there'll be a skip and then we'll be closer on, because this seems like a pretty extreme delay. As long as the audio isn't out of sync, that's the main thing. Okay. Good. So, anyway, I'm kind of interested, actually, in hearing some feedback from you guys about Labs 9 and 10. How did you find them? Did you find them interesting? Did you find the material interesting? How was the difficulty level? I know that Lab 10 is a bit on the more difficult side. Lab 9 would have been more strict procedure following. But yeah, anyway, I'd be interested in hearing that. Your impressions of the two labs from last week. Oh, shoot! I almost forgot. Course evaluations. Yes. Yes. So, evals.mcmaster.ca. There we go. Course evaluations are open this week. Evaluate and make a difference. Doop-a-doop-a-doop. Summer, here we go. So they are opening Tuesday, today, 10 a.m. So they opened 37 minutes ago. The course evaluations close Friday midnight. So, if you would like to have your if you would like to have your voice heard with respect to this course, or my teaching, or the TA's, or any of that kind of stuff, this week is the week to do it. So, let's boost up this guy in favor of Linux, eh? Come on, we can do it. Linux, Linux, Linux. Anyway, so I would be particularly interested in what you guys have to say about this course particularly this semester, because as a lot of you probably know, the I've been doing a fair amount of curriculum revision this semester to, shall we say, align the course more with the expectations that the department had when they set up the course, which was that it would be an experiential course. And I'm interested to know whether, you guys, like, what you thought about it. All of your I'm soliciting general comments about the course. Like, I'm very, very interested to know how you found the course, whether you thought the course was useful. Have I been putting things in the course that seem useful? Of course, you won't know if they're useful until you start working out in the job, but, hopefully, like, I'm trying consciously to make the stuff in this course useful to you. So, yeah, like, I would be very interested to know what you guys thought of the course overall, and of course the course evaluations are the ideal way to do that because it's in a structured manner. So, lab feedback. Lab 9 and 10 were harder for me, but I found Lab 9 more interesting. I found Lab 9 really interesting as I was putting it together too. Okay. The oxygen was neat. Yep. Lab 10 was quite difficult. It was cool, though, that I could do so much with one line. Yes, yeah. Like, I know, the only way that you're able to get good at those particular types of commands, unfortunately, is practice. So that was sort of my design ethic for Lab 10 was, well, practice, And, throughout this course, there's also been a thing running under the surface of the course. If you don't understand it, I encourage you to check Stack Exchange, right? So a couple of the questions on Lab 10, I intended for you to go look up on Stack Exchange or some other website, how to do a particular thing with a particular flag using sed. Those are the ones that come to mind immediately. Is like, there was one where it was like, perform the X replacement in the first 100 lines or something like that. And you can do that with sed, but you have to look up how to do that with sed, right? So, yeah, but also I was kind of looking around on the internet for a set of exercises like that for find grep and sed, and couldn't really find one. So I was like, okay, I'll just make one then. Not a good one, anyway. So anyway, yeah. So let's talk about the C preprocessor. Incidentally, I just realized this morning that my use of the term errata is actually erroneous. Errata means corrections. So what I should say here is the C preprocessor and miscellaneous appendix material. You can think of this course as the appendix. You can think of this lecture as the appendix lecture. So let's talk about, primarily we're going to talk about preprocessor directives and signal handling. So, we've talked about quite a lot in this course. We've brought you guys up from basically no knowledge of C, aside from that which is transferable to Python. And we've brought you through how I/O properly works in Unix-like environments, what pointers are, what how strings and arrays and how strings are character arrays, how arrays behave, the fact that C doesn't check you for your array usage, all of these types of things. We've talked about structures. We've talked about pointers and structures and how they interact. We've talked about dynamic memory allocation. All good C stuff. So what's left? It turns out not much. C is a very compact language. Whereas with with Python, there's a fair amount to learn. Although Python is also a fairly compact language, relative to something like C++. C is a very small, has a small subset of language constructs. So it is actually possible to learn everything that you need to know about C over the course of a half course like this, as long as you put the time into practicing it. But one of the things that we haven't talked about is the advanced preprocessor commands. So let's remember what preprocessing is, right? If we think back to all of the stages of compilation, the first stage of compilation is preprocessing. Preprocessing, it can do a number of different things. So far, the only thing we've been using preprocessing for has been include statements. Include statements are a type of preprocessor. Everything that has the octothorpe character in front of it, that is a preprocessor command. So commands that are given to the preprocessor are executed by the preprocessor and then never dealt with again, right? The correct way of thinking about this is these are tags which manipulate the underlying source code. It's incorrect to think of these macros as being part of the code itself. They're another layer on top of the code, and there's actually a lot that you can do with them. You can do some proper programming in them, actually, but generally speaking, we reserve the proper programming for the proper programming language. The other thing that you'll find about these guys is that you'll find analogs for them in many languages, these types of pragmas and macros. Most languages will support this type of construction, and they're also reasonably, in principle, they're reasonably similar to the manner in which you would do if statements in a bash script. But I'm getting ahead of myself. So here are some of the advanced preprocessor commands in C. Define, undef, if and endif, error, pragma, and line. The C preprocessor is responsible for handling all of the operations that need to occur before a source file can be tokenized, and an abstract syntax tree generated, and the executable generated from that. The first step, of course, is the removal of comments. Comments are not part of the eventual source code, and have to be removed before the compiler compiles the code, because they're not meaningful code, right? They're meaningful to us, but not to the compiler. GCC don't care nothing about your comments. Preprocessor directives must then also be processed. A preprocessor directive is some manipulation of the text of the source file. That is essentially your definition. all of these guys are operations on the source of the file itself, not on the program. Like, we have to make a mental distinction between the algorithm and the file, right? We have to distinguish between the the science fiction story and the paper that it's printed on, right? With these preprocessor commands, it's like operations on the paper, not on the words of the story, right? That's a good analogy for it. Macro man. At the beginning of the course, we actually skipped this. Macros can set symbolic constants, but we can use them more for just deciding the size of an array. So, define, identifier, replacement text. A macro is a character substitution operation. So, let's get it. Example.c. Let's say, just for the sake of interest, we wanted to define. Well, let's import or include stdio.h, because you always should. Let's have int main void print hello world. There we go. Your basic C hello world. Now let's define some stuff. So let's say open main becomes int main void. There we go. Open main. Let's see if this works. Gets me every time. Okay, there we go. So, this is not valid C code, right? This is a macro. I've defined open main to mean int main void. So when the preprocessor is finished with this file, basically it copies this in, pastes it where any occurrence of open main is, and Bob's your uncle. That's how a macro works. And notice, so as we're talking about macros here, you might be more familiar with the idea of macros as they exist inside of something like Microsoft Excel or Microsoft Word. They're kind of similar ideas, but generally it's better to think of macros in the sort of Microsoft Office sense as being small scripts which you can execute, rather than being, direct character substitution. Now, it's probable that sort of in the beginning, it's probable that macros were originally character substitution operations in something like the very early versions of Microsoft Word. However, they've since evolved and taken on a whole new character, and I believe you can script them in Visual Basic. I'm pretty sure that the macros, it's either macros are Visual Basic or macros can invoke Visual Basic scripts. One of the two of those. But this is something else entirely. We are talking about straight character substitution. So, for example, if I were to take something that's obviously not syntactically correct, like define words, I don't know, to mean, where's my mouse? There we are. Like this portion here, right? And then I type words. Let's see what we get. They don't like these. There? No, okay. So they don't like quotes. So we'll just leave the quotes there. Okay. Well, all right, so there are limitations. If you do it inside of quotes, then that's problematic. But in general, if you use it like an identifier, it'll work. It's always interesting to find the edge cases during your lecture. So, anyway, remember that a macro is a character substitution operation. This means that a macro can be used to insert anything into a C source file, including semicolons, curly braces, complete or partial expressions, assignments, argument lists, and function calls. Macros have, well, they have a few grammatical limitations, though the substitutions they make must result in grammatically correct C code. What if you do %s? Yes, that would definitely work. World. Probably have to be in quotes. That would probably work. Yep, that works. There. A clever student was cleverer than the professor. There you go. Thank you. Yes. So, it is recommended to keep these substitutions to one line, and macros are named in all caps by convention. Oh, okay. Open main words. There we go. So, here are a few macros. We can have begin, twice, int print, area. We have all of these guys. So I showed you just simple macros, but we can get much more complicated with this. So it turns out that you can also give parameters to macros. These are sort of accepted in the same way that your rules for dealing with these things are, yeah, awesome. Your rules for dealing with these things are fairly similar to the rules for scripting languages. Bash scripting. Whatever you put in here, that will end up, basically this is a macro within a macro, right? X is a macro within the macro twice. So whatever you put in here will end up being put twice into the file. Again, these expressions can be fairly complicated. If you find it annoying to have to write printf, %d new line all the time to be able to print an integer, you can rename it to print int, and it'll just take something and do it. So, essentially, if we were to expand this guy out, I'm just going to do it down here. Oh, every time. I need to find a different way of doing that. Int main begin gets expanded to this guy. If 1 is equal to 1, int print gets, so int print gets substituted for printf, %d new line, something, area 810. Area 810 gets replaced with 8 times 10. That might seem like a lot of brackets, but when you're performing this type of character substitution, it's often useful to include more brackets than you need, because you don't know, like, you could easily do, like, 8 plus 6 or something in here. And then if you didn't have the brackets there, then it would be 10 times 6 plus 8 because of order of operations. So it's really just safer to put everything in brackets most of the time. And, of course, that's syntactically correct C code. Macros with arguments. You may have noticed the program on the previous slide contained macros with a function-like construction. Yes, you can make your macros take arguments. The process somewhat resembles lambdas in Python, if you remember lambdas. The main difference, of course, is that we are performing character substitutions only. So the arguments to a pragma may be any group of characters, so long as the operation results in valid C code. For example, the macro twice x takes the input x and inserts 2 of them into the file. This is used to duplicate the closing brace ending main and its if statement, right? So we're ending both the if statement and main using twice and curly brace. Cool. Man, my computer gets hot. So, if you wish to undefine something, that's also possible. So, by default, these define statements apply to everything. They apply not only to the source code file in which they occur, but they also apply to any source code file which includes the source code file that the define exists in, right? It sort of propagates through your entire program structure. In fact, that property is often used of macros. Like, often all of the macros that you use in a large C program will be separated out and given their own file, like they'll be contained within their own file, and then imported, and then everything has that same structure. Or every file would then have those same substitutions. However, this sort of global applicability of define statements may not be desirable in all cases. If you want, you can remove the macro using undef. Remember that macros are also imported when you include a library or one of your own source files. By using undef, you can prevent macros you define in one file from being applied to another. Once a macro has been defined, it can subsequently be redefined. So it can also be useful if you want a macro to perform different substitutions in different parts of your source code file. However, this does not necessarily seem like an advisable use case, as it seems like you're starting to get into spaghetti code territory, which is not recommended. So, So that's define statements. So let's talk about if and end if. We can hide code from the compiler conditionally using if and end if. So if you have an if and then a condition, you put code which might be deleted inside of it, and then end if to close off that block. Any code between if and end if will be deleted if the condition evaluates to 0 and kept otherwise. The conditional expression must have integral type, that is to say it must be an integer, and can only include integer constants, character constants, and the defined operator. Remember, this command is being executed before your program compiles. As such, functions, variables, enumerations, and type defs should not be included inside of if and if. If you include a type def inside of here, if the condition comes out false, the type def won't be included in the source code for compilation, which means that you'll have a bunch of references to an undefined type, which is generally not what you want. Best to stick to macros, integer literals, and the standard operators. So, common uses of if include preventing a header file from being included multiple times in the same project. This is actually a problem. Ooh. Okay, I have a question. Macros seem like a sneaky way to have code in a program. By chance, do people use this when making certain malware? Ooh, well, I don't know, because this is not Defense Against the Dark Arts, so I don't know all that much about how they make malware. Generally speaking, now this is generally like, this is kind of me speaking off of the cuff about things I'm not an expert in, but my general impression is that macros, like, in order for an attacker to inject code using macros into your source code, basically that attacker has to modify some of the files on your disk, which is not easy, right? And once those files are modified, the attacker then has to either wait for you to invoke a compilation process on the modified file, or the attacker somehow has to induce a compilation of the file, right? So, in general, like, the protections on files and processors are such that if you had that level of access, you wouldn't need to leave these types of malware inside of code. Now, is it conceivable that someone would, like, get in with temporary access and then, like, leave a door open for themselves so they could get in later? Maybe. I don't know how helpful define statements would be with that. Possibly. But generally speaking, when you're trying to infiltrate a system, you're going to be going for sort of memory exploits on processes that are already running most of the time. Like, going after files is generally, like unless you have managed to, as an infiltrator, if you have managed to acquire root access, like, that would be one of the few situations where you have the level of privilege necessary to be able to mess with a user's files. And generally speaking, if you have root access, like, you don't necessarily need to, you don't need, like, you already have all the access you need to do whatever damage you want. Unless you're setting it up so that you can come back later and mess with people's stuff and regain root access after you've lost it because they found you out, or something like that. So, you know, is it conceivable? Yeah, I could conceive macros being useful. But, generally, any attack like, I don't really consider things requiring recompilation to be a highly effective attack vector. You're much. I think going after the RAM is a much softer target than going after the ROM, generally speaking. But, you know, that's just my little digression. So, yes, preventing header. So with header files, in a C project, if a header file is included more than once, it gets basically it just duplicates all the definitions in it. And if you're using header files to define things like type defs and stuff like that, you can run into problems. So if can be used to prevent that. Giving a program a debug mode. This is actually one of my more recommended. You're welcome. Typically, in debug mode, a program will execute many printf statements which reveal internal data or generate a log file. So we've all been in this situation, right? Where, you're writing a program, you're putting in all kinds of printfs because you're trying to debug the program. And then once the program is debugged, you either comment out or delete all of the printfs that you included. But if the bug comes back, then you have to re-enable all of these printf statements. If you if you put all of these printf statements inside of an if-def that toggles whether or not those printf statements occur, you can in fact compile the program either in debug mode or not in debug mode using a compiler flag, and then the printf statements will either show or not show based on a flag that you've set from the command line, which can be extremely useful. It's actually reasonably similar to verbose mode, right? With a lot of programs, they'll have a verbose mode where that basically toggles a whole bunch of print statements that display, the goings-on inside of the program. It's generally considered good form to only bother the user when the user needs to be bothered. Overuse of standard output can be problematic. Latex is the worst for this, right? Let me show you something. CD home /documents. No, is that root? No, that's home. Is it? Whatever. Documents. It is home. Oh, it's home, not, anyway. Not my user's home. So this is my thesis. It's a huge, long LaTeX document. And, look at all this crap that that LaTeX generates every time it generates a file. Like, look at all of this crap. And now, to be fair, I'm running this program 3 times, but that's just like LaTeX is very bad for that. And most of the information is like impossible to, like, it doesn't mean anything to you as the user, you know? Like, what does this mean? Who knows? You know? What does LaTeX font warning font shade OMS CMTT MN undefined using this one instead? Do I need to know that? Do I need to know that? Probably not. But anyway. The rules for good technical writing are actually the same as the rules of good writing in general. Don't waste the reader's time. Anyway. So we can also use ifdefs to set different constants or executing different statements depending on system-defined values. So if you take a look at things like standard library, there are a bunch of things that there are a bunch of constants that are defined for your particular system architecture. Things like the word size of your CPU, right? Or the amount of memory, total memory available, stuff like that. I don't know if that's actually one. Pretty sure word size is, though. Yeah, the word size of the processor, the version number of the operating system, or any other number of things. So these ifdefs allow you to include or exclude code based on the operating system version, which can be extremely useful. This assumes the program will be compiled from source on multiple different systems. So this is not so much a way to write portable code, right? But if you're, really getting into the weeds with, the features of particular operating systems or hardware, this is something that you might need to worry about. But in most cases, you won't. So, if variants. Here are some quality of life improvements. The defined operator returns 1 if the specified macro is defined, otherwise 0. Elif and else may be used the same way as else, if, and if to create additional branches. Or, that should say else. If def x is shorthand for if defined x. If ndef is shorthand for if not defined x. You can use if to comment out blocks of code. Yes, you can also use if to comment out blocks of code. Using actual comments doesn't allow for nesting, but if and endif do. So if you want nesting in commenting out blocks of code, then ifdef if is the one that you want to go for. Here are some miscellaneous error tokens, prints an error message. What the error message says depends on your system and C implementation. This halts compilation upon execution. So you can terminate compilation using the error directive. Pragma performs miscellaneous commands. Which pragmas are available depends on your system and C implementation. Using pragmas may make your code less portable. Pragmas tend to be system-specific. But, if we were to take a look in, C pragmas in Ubuntu. Yes. You would have stuff like GCC dependency, allows you to check the relative dates of the current file and another file. If the current other file is more recent than the current file, an warning is issued. This is useful if the current file is derived from the other file and should be regenerated. So make is using this guy. poison, sometimes there is an identifier you want to remove completely from your program and make sure that it never creeps back in. To enforce this, you can poison the identifier with this pragma. GCC poison is followed by a list of identifiers to poison. If any of those identifiers appears anywhere in the source after the directive, it is a hard error. Haha, keywords. That's interesting. Very cool. So, let's talk about our final topic today for this course, signals. C does not support exception handling. Python does exception handling. C does not handle exceptions. Instead, it handles signals. It handles signals instead, which, as with most things in C, are not quite the same thing. For each process, the operating system maintains two integers, which indicate the status of various signals. One is for pending signals, the other blocks pending signals. So, this is a register inside of your CPU that's keeping track of status flags. So, rather than, like in Python, exceptions are a class, because Python is object-oriented, and everything is a class, right? Everything is a class or an instantiation of a class, including the exception handling mechanism. In C, you don't have a dedicated exception handling mechanism. What you have is flags in your actual CPU, which get raised if bad operations occur, and C can watch these flags. So it's a different system. The signal handling library of C is signal.h. This library contains a number of defined values, which indicate various signal types. Most of these signals correspond closely to the types of exceptions you saw in Python. For example, sig.il is illegal instruction. Sig.int is receipt of an interactive attention signal. So sig.int, you can think of that as interrupt. So sig.int is when you hit Control-C on your keyboard to terminate a program, you get sig.int. Sig.abort is abnormal termination of the program. So if the C program calls abort, then sig.abort occurs. Sig.fpe is an erroneous arithmetic operation, such as a divide by zero or an overflow operation. So there you go. And a termination request is the type of thing that you would do if you tried to kill a program using htop. So, yes. Yeah. We have an example here, which is fairly long, but I don't have to copy it. I have it in code. I just have to look it up. So, not handling, not exceptions. In order to handle a signal, you must register a function to activate for an incoming signal of that particular type. If you know other programming languages, this is kind of like the idea of a listener in C#. If you know what a listener is, this is kind of what a listener does. The signal function is provided in signal.h. The function associates an incoming signal type with a function. If the signal is received during program execution, execution is paused and the function is immediately entered. Once the function is terminated, the association between the signal and the function is broken. So this is a single-use association. Fortunately, it is possible to call signal from within the signal handling function. So the signal can reestablish the signal relationship, but every signal that this function handles, that breaks the association. So Here is a long but somewhat humorous example. So we are including stdio.h, signal.h, and uni.std.h. We have a global variable finish, which is equal to 0. Handle sigint, int signal value. This is our function which handles the signal. We have our main function. We associate sigint with handle sigint, right? So we have associated the interrupt signal with this function. So if we receive this signal, we will enter this function. Printf, let me tell you a joke. While, if finish, you do all of this printing stuff. Else, you print this other stuff. So let's take a look at how it works. Code. Right. Get it. Bananas. Or I suppose I can just cat it. So this is our program, bananas.c. The tab level is not completely consistent. I apologize for that. But this is the program that we were just looking at. So if I compile that guy, GCC, and a .out because I didn't specify a file name. Let me tell you a joke. Knock, knock. Who's there? Banana. Banana who? Banana, na, 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 nana. Knock, knock. Who's there? Banana. Banana who? Etc., etc., etc. So what this program is doing is it's just looping through this knock, knock joke until such time as I Control-C it. Now you'll notice most of the time a Control-C terminates the program, but in this case it changes our state so that when we say knock knock, who's there? Orange. Orange who? Orange, you glad I didn't say banana. The other half of the joke is printed, but not until the program receives the... Uh-oh. Uh-oh. Am I still coming through? Am I still coming through? Successfully reconnected. Let me just check to make sure I didn't lose anything here. Okay. So, okay, cool. Uh-oh. Okay, good. So yeah, it will loop through and give the first half of the joke until the user tries to kill the program, in which case it switches to printing the other half of that joke, and then it terminates. So yeah, that's how you handle signals. Once again, there are a reasonably large number of these things. This is just a sampling of them. Again, this will be in the same way that pragmas will be to some degree system specific. Some signals will be system specific, but these guys here should be available in pretty much any environment that you might want to use them in. If you were my 2MP3 class, I would say, and that's how a hardware interrupt works. So when you are asked to do hardware interrupts when you're doing your embedded systems programming, you'll know how to do it now. But of course, you guys probably will not ever do embedded systems programming. It's a very specific thing. It's like programming, but not with computers. But anyway, Congratulations, you magnificent human beings! This concludes our discussion of the C programming language. Students, now we know everything there is to know about C, the prof. Well, yes, but actually no. So, over the course of this course, there were a few things about the C programming language that we did not discuss, which sort of, in the view of your humble professor, are not like, uh-oh. Yeah? Okay. Yup. In the view of your humble professor, these things are either easy enough to figure out, sort of your own study, or, you know, basically, you've got the bones, now you need to put some flesh on them, right? This is your task. You must, if you want to expand your knowledge of C, then, you know, there are a few other things you can deal with, like unions. Unions are similar to structures, but not quite the same thing. From here, it's really just mostly practice. If you want to expand your knowledge of C from here, then you really should be thinking about taking up C++. So, I would just like to speak briefly in praise of C++. C++ is a proper language. Like, a good C++ programmer can do everything that a Python programmer can do, probably faster than a Python programmer. Well, Python's a pretty fast language. C is a slow language because it forces you to work in all kinds of low-level constructs, right? But with C++, basically it took C and it gave it all the abstractions that it needed to bring it up to the level of a very properly instantiated, fully object-oriented language. Now, the interesting thing about C++ is that it is a superset of C. So every C program is also a valid C++ program, but not all C++ programs are valid C programs. So every single thing that we learned in this course about C, that will help you in C++. There's a reason that they say C/C++ everywhere, right? So if you really liked C as a language, like if you prefer this to Python, the natural place for you to go from here is into C++. And I will tell you right now, C++ it's one of the more difficult languages to learn, but that also means it has an extremely high skill cap. The thing about Python is I feel it has kind of a low skill cap. It has a low skill ceiling, and if you don't know what that means, it's like video game terminology. It means you can, like, a very skilled Python programmer comes up to a certain level. A very skilled C++ programmer comes up to a much higher level. Like, the skill, you get more benefit from the skill that you put into C++ than the benefit from the skill you put into Python, in my personal opinion. So, yeah, we're not, of course, covering any C++ here, but if C++ is a language that you are interested in picking up, I personally consider it to be a highly employable language. Especially, like, the thing about C++ is that it was very popular for a long amount of time, which means there are a lot of companies that still work with this stuff, and not just for legacy. Like, C++ is a language of active development as well. Like, to some extent with C, you can say, well, C is like, if you're working with C, you're mostly going to be working on legacy stuff that was written in C. But with C++, there's still active development that occurs with C++. It's an extremely hard, extremely. It's a difficult language to learn. So if you learn it, it sort of puts you in a different category with respect, because it's more difficult, fewer people learn it, which means that you stick out more from the crowd if you know C++, if that makes sense. And, when a company is hiring a C++ programmer, they do not care if you know Python. They only care if you know and are good at C++. So it kind of silos you a bit, but it's extremely, extremely useful, and in my opinion, an extremely employable language. So yeah. Anyway, that's just what I wanted to say about C++. So it goes Python to C to C++. Well, that's the progression that you could have in, there are a large number of different ways that you can pick up programming languages, right? At one point, one of my friends showed me full stack developer skill tree. There was yeah, maybe this is it. I hate this. Just show me the friggin' picture, man. Yeah. Yeah, here we go. So, it's reasonably popular these days to aim for being a so-called full-stack developer. This has to do with a lot of web technology, so this is kind of different from the stuff I'm talking about. But this is, if you just Google full-stack developer skill tree and look around, you should find this. But you can see they consider the basics HTML, CSS, and JavaScript, so learn some of that stuff. Then it's got all these other technologies. I'm not sure how old this is or whether to what degree this is still applicable, but back-end roadmap. This is more what we're talking about when we're talking about C. So PHP, Node.js, Ruby, and Python, right? Sure. Then C#, which is .NET, Java, and Go. Okay. Oracle, MySQL. Yes. So it's really more okay, DevOps. Maybe this is, so operating system, Linux, Unix, automation. Yep, this is some of the stuff we were talking about today, or in this course. Yep. Docker, yep. Bash scripts, yeah. So, of the three roadmaps presented here, which incidentally absolutely do each individually represent a career path within the sort of modern software development community, this course is definitely focused more on getting you guys on the first rung of the ladder with respect to DevOps. So, hopefully you guys know some operating system stuff with Linux, Unix now. But, yeah, so, basically to be a proper software developer, you have to know a lot of shit. But, yeah, and, you may have noticed that C++ doesn't exactly exist on any of these. But that's because it's not exactly used for web technology. So, and a lot of the jobs right now are web involved, shall we say. But that doesn't mean that other stuff doesn't exist. What is C#? Good question. C#, incidentally, if you have any of those, if you have any questions about the course or the exam or anything, I'm opening the floor to those now while I answer Alex's question about what C# is. So, C# is intended to be a successor language to C++. So C, for you guys, C is, a very important language. C++ was the increment of C because, of course, you guys now know the ++ operator, so C++ is C incremented. The clever thing that C# was supposed to do was to take two ++s and stack them on each other, because if you type +++++, it looks like a sharp symbol. So C# is C+++++. So in terms of the like what C# looks like, I do not believe that it is a proper superset of C++. I'm pretty sure that C# goes in a different direction. It's more Java-like, actually. So if you I kind of hesitate to say this, but C# is kind of Microsoft's Java. They took pretty heavy inspiration from Java to create C#. So, like, I've been called out for saying this before because, oh, you can totally compile C# in Linux, but it's like, yes, but it's the .NET framework, which is specifically, like, Microsoft is the vendor. So, yeah. Anyway, so, questions. Let me write some of these down. I will answer them in some kind of order. What will the exam mostly cover from the course? So, exam coverage, double pointers, okay, pointers IO. I should have a review session as well. Office hours before the exam. I might just have a review session out before the exam, actually. Okay, quick poll of the class. When would it be convenient for you guys to have a review session? Malloc and free, so dynamic. Will the topics in this lecture be on the exam? No, not generally. If you find them useful on the exam, you're allowed to use them, but I'm not going to test you on signals, for instance. So, let's talk about the exam coverage. So, in general, the exam coverage is pretty much everything. We haven't had a test, right? So it's not like we're going to be testing primarily things after the first test. So there will be some pointers stuff. There will be some structures stuff. There'll be some string manipulation IO type stuff. You'll have to know your basic constructs, of course. You'll have to know how to work with arrays. I'm also going to work in some stuff like makefiles and documentation into the exam. Maybe bash scripting, but actually I'm not entirely convinced that I'll end up putting any scripting in the exam. I've noticed that the marks are not super stellar this semester for one reason or another. You guys are busy with a lot of crap, I guess. So I'm intending the exam to not be overly difficult. It's kind of like, I'm not going to be testing you on a bunch of difficult math, if that makes sense. it'll be more like, are you conversant in C? Have you picked, like, were you paying attention in the labs? Do you know how to make a make file? That, you know, um, can you work with some elementary data structures? You know, like, there's not going to be a huge amount of difficult algorithmic stuff, because I don't even, like, that's not what I view the purpose of this class to be, right? The difficult algorithmic stuff, that's, you know, that's the purpose of 1DM3. My purpose is, like, developer stuff. So that's the thing I'm going to be teaching, or that's the thing I'm going to be testing on, right? So documentation, you know, make sure you understand how Doxygen works. Do not be intimidated by makefiles. We did makefiles a few times in the we did them a few times in the lab, so hopefully you guys are good for makefiles. Friday. Yeah. Good. Will there be bonus questions in the exam for extra marks? Haven't decided. We'll see. I haven't decided about the bonus marks. I might give it to you, see how people do, and if I think the average is too low, I might lower the denominator. But like, I don't want to do like a, it's like, for me, I haven't done an exam in this style before with students, so I don't know what you guys are going to, I don't know how you guys are going to react to it. Like, what are the, like, if everybody gets 110% on the exam, like, I know that sounds like, you know, hooray, hooray, from your perspective, sure. But from my perspective, it is important for me to get something resembling a grade distribution. Otherwise, I'm not testing you guys at your level, right? So, yeah, we'll see. If I make it too hard, I'll adjust it in post. But I don't think I'm going to make it too hard. How long, how many questions will there be on the exam? Is it comparable to an assignment? No, I don't think it'll be comparable to an assignment. It will be more, I don't know. At the moment, it might be shaping up to be like 2/3 to 3/4 of an assignment, maybe? I don't know. It's difficult because I haven't hammered it out completely yet. I've still got some work to do on it, so. But yeah. There will be some easy marks on it. I guarantee you there will be some easy marks. Asterisk, so long as you know your basic constructs. But yeah. One thing that I am expecting you to be able to do, though, is use, like, I'm going to provide you, yeah, I found a lot of the lab assignments hard because of how quickly the course went, so if you make the exam easier, yeah. I mean, again, it's gonna be, I want it to be a rigorous test of your skills, of course, but I also know that, you know, it's, you know, relative to certain exams I've set for 1MD3, for instance, it's not going to be as difficult as a 1MD3 exam, I don't think. But yeah, one of the things I'm going to do with the exam is the exam is going to operate like the program. Okay. It's going to be one big program with, like, the various files and functions broken down and described. That's the form of it. And this big program, which uses all of these components, it's going to be, like, you'll interact with it using standard input and standard output. So I'm going to be providing test cases for this program in the form of captured standard input and standard output streams. So you'll have to know how to use piping in order to, you know, like if you know piping and diff, that will help you. Okay? It's just hard to keep up with the labs and assignments being due on the same day. Yeah, it's... Normally, labs would be due at the end of the lab session, right? But, you know, I would say something like, you know, the idea, the intention is that, you know, not everything gets done the day before it's due, right? There's a certain amount of, you know, I set an assignment for 2 weeks, so I expect you to be working on it for 2 weeks, right? So, you know, I get that life gets in the way, but, you know, it's kind of, you know, the labs are supposed to be done in the lab session, so, unfortunately, like, there was only so much I could do, you know? But, anyway. So that's, I guess, that's me having talked about exam coverage and talking about the exam in general. Like, you know, I would say, please set aside a decent chunk of time for it, just in case, you know, you have difficulty with this or this part or the other part of it, you know. But in general, you know, please don't be scared of it, because it's not trying to kill you. It was you were doing another course at the same time. It really helped for it to be due later. Yeah. Well, it's kind of funny in the summers anyway, because like, especially with the online component, like normally for a summer course they book evening classes, right? Because they assume people are working. But with the online course, the assumption is that if you're working, you'll catch it in the evening, right? So that's, you know, that's in part contributing to the fact that we have, what, 11 people, 12 people concurrently viewing right now. So, yeah. Like, if it was all due all at the same time, like, if you had to walk into the lab, do the exercise, and then submit it, like, that would reduce the homework load, I think. But, you know. I was given a certain number of lemons, and I had to make a certain amount of lemonade this semester with it. But hopefully everything worked out. My impression of the grades from the grades from the labs are kind of interesting, because they split, like, really hard between, like, 100% and 0 for most of them. Like, take, for example, Lab 6. Right? Like, look at the split there. You know? Most, like, the majority of people who attempted Lab 6 got 100% on it. Right? You know, this is not precisely the case for something like Lab 3, which, you know, that might need to be reworked in another offering. But even with Lab 3, you know, a fair number of the people who attempted it, like the largest category of people who attempted it got 100%, right? So, you know, despite the fact that all of these zeros make the average look like 50%. It's interesting. There's been a lot of sort of non-participation this semester for whatever reason. Yeah, with Lab 4, you can see, Like, people who do it tend to do well, you know? But, at any rate. Assignment 1 had a more normal grade distribution. Like, that's more what I expect for assessments, you know? The zeros are not included in this one. But yeah. So, yes. In favor of making it shorter but more difficult. Well, I mean, it's gonna be what it's gonna be at this point. But yeah, it's gonna be what it's gonna be at this point. So, I have a little bit of time, so let's talk about a few of these specific things. You guys want me to go over pointers and double pointers and dynamic I/O, so that's kind of all clustered around one topic, actually. So, quick review. Quick math. Int main. Get rid of this stuff. So, quick review. Pointers. If you have something, right? If you have a variable corresponds to a location in memory. So if x is equal to 3, then what we have done is we have taken the value 3, put it in a cell of memory. Using the ampersand operator, we can actually directly use and manipulate the addresses of these memory cells in our C program. So if we have x pointer equaling the address of x, then we can the value contained in P is D. And then we can have x pointer and dereference x pointer. So the star, of course, converts something to a pointer of the carrier type. In this case, it's an integer pointer. If we execute this program, GCC example, gets me every time. I do too much Python programming, gosh darn it. Yep. Let me just put a new line in there. There you go. The value contained at that memory address is 3. Pointers. So far, so good. So the thing is, when you have an array, let's say y, containing 10 elements, let's say the values 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, y itself is just a pointer, right? A pointer which can't, like, this, the square braces is actually pointer dereferencing with offset. So, if we say for int I is equal to 0, y, or I is less than 10, I plus plus, you can see the y plus I and y at I. Hopefully this works. Yes. So we can actually use y directly using arithmetic because it is a pointer, right? So if you add 4, that's the size of an integer, repeatedly in succession, you can get at each of these individual elements. In fact, it's also possible to, save the value to the pointer itself and move it around that way. But generally speaking, you want to try to avoid pointer arithmetic wherever possible because it just messes things up and is difficult to debug. Maybe later. Speaking of A1, I added the TAs to it as soon as I saw the post. So if you don't have your mark for A1 now, talk to Mark. Could I do a review of documentation and make files? Not now, but why don't we make it so that there's a review session on Friday? Maybe I'll put a poll up. No, I'll put a poll up on Piazza, see where people want the review session. But sometime late in the week, I'll do a review session to do these topics. Okay, guys? So docs and make files. Hopefully by that time everybody will have seen this lecture. Recursive algorithms for trees. Yes. I don't generally say X will not be on the exam because all that does is invite, a million people saying, will X be on the exam? Will Y be on the exam? Will Z be on the exam? And then they can determine the exact content of the exam through process of manipulation, or process of elimination, not manipulation. Pardon me. So I decline to answer whether or not trees will be on the exam, but yeah. Ah! I don't do participation marks. Sorry, Alex. No, I don't. No. No. That would be unfair to people who, have to actually work during this time, right? They shouldn't have a disadvantage in their grade, because, they couldn't come to a concurrent class. But I would like to thank everybody who is a regular attender of the lectures. It's, it would just be depressing if all I was doing was doing live streams, but I might as well have just been recording videos, But yeah, so structs as well. So let me continue on about pointers then. Yeah, can't blame a guy for trying. I can't blame you for trying. But, I have standards to maintain, my friends. So, double pointer, then. Most of the time you see a double pointer, it'll be because you're passing a reference by reference. So this is most useful when you're working with functions. But because X pointer, for example, is a concrete value that exists in memory, it is possible to get the address of a pointer, right? X pointer. So, and you can actually chain this forever, right? So a double pointer is just a pointer to a pointer, right? A triple pointer is a pointer that points to a pointer that points to a pointer that points to the actual value, right? So normally what you do with these is like you would take the address of one of these guys and you would pass it through functions. Quick tip for dealing with double pointers. Just print them. Like if you do a print statement before a function is entered and a print statement after the function is immediately inside of the function, comparing the input that you gave to the input that you received, That's like, and then you can use that to like find the proper level of dereferencing that you need for the particular situation. Honestly, I love your live streams. Makes my day with all your references and puns. Ha! Thank you. Thank you, folks. I assumed that you guys were continuing to attend because you were enjoying the process. But yeah, like you know, computers are hard and stuff. Math is hard, you know? It's the least that we can do while learning math is try to have a little fun with it. Could you manipulate the value of the input through a double pointer? Yeah, you just have to dereference it twice, right? So if I say, for example, x double pointer dereferenced twice is equal to 6, for example, then x double pointer dereference it once, dereference it twice. Gotta compile. Yeah, there you go. It's 6. Whereas if I do that with, you know, if I do that before the assignment statement, and I do x pointer and dereferenced x pointer, it's first it's 3, then it's 6, but the same address. So there you go. Yes. Yeah, so, you know, double pointers are... To be honest with you, there's, like, most of the application of double pointers is passing passing arrays by reference. Like, for example, and I know I said we'd do the dynamic stuff, but I'm not, but maybe we'll do the dynamic stuff next. But with a double pointer, like you'll see sometimes these like the string functions come to mind, right? Let me just see here. Do we have any here? Well, one of the things that double pointers are used for is implicit return values of pointers, right? So, again, remember that when you pass by reference, the function can just drop data that's been calculated into the namespace of the calling function, right? Of the parent function. So it can just drop data into the parent function using the reference. If the thing that you have to drop is a data, like it is a pointer, then the appropriate thing to do is to have a double pointer as the input. So a good example of this is the stack question, right? So when you are pushing something onto the stack, right? If the stack is represented by a pointer to the first thing in the stack, and you know this would also work for linked lists. If you're okay, let me change this. Let's make it into prepending a linked list, right? So you have a pointer to the first element in the linked list, right? But the node that you want to insert is at the beginning of the linked list. You can do an implicit return on the pointer to the beginning of the linked list, assuming the index assuming the argument gave you the pointer to the first element as a reference, as a double pointer, if you dereference it once and update that pointer if you have to add something to the beginning with the new, with the address of the beginning thing, then, that is a totally legitimate use of a double pointer. But, yeah. That's what I say. Cool. So, yeah. I guess the rest of this we will talk about during the review session. Hopefully that was useful for you guys. But yeah, I guess that's it. Thank you very much for your time and attention. Personally, I've really enjoyed teaching 1XC3 this semester. I feel like my own skills in the topics being presented have been improved quite substantially by having gone through this journey with you guys. I like taking on a new course for that reason. So for the review session, we're going to have a poll on Piazza with some time slots, and whatever the preferred time slot for everyone is, that's when we'll have it. No trouble. So, yeah, no, I've really enjoyed this course. It was quite a lot of work to put it together because, I know you guys were like, oh man, these labs take so long, but it takes much longer to create them than for you to do them. So, yeah. I hope yeah, thank you. Thanks, everyone. My primary goal with this course has been to try to make it as, practically applicable as possible for you guys for the future. Okay. You now know, hopefully, a lot of stuff about C, right? You know the tools that you have at your disposal for proper C development. But this is not where this stops. Now that you know that these types of tools exist, it is your prerogative, whenever you're programming with any programming language, to look for the equivalent tools to the ones we covered in this class. You notice Doxygen covers actually a fair number of different programming languages, right? There are equivalent tools to all of these things with pretty much every popular programming language. You probably won't find them for COBOL. But certainly, Java, C#, C++, obviously, because it's the same as C. Python has these types of tools. Makefiles can be used for anything. I demonstrated during this very lecture how I use a makefile to build my thesis, which is a LaTeX document, right? I can show you well, you don't need to see it, but the general operational principle of makefiles has been iterated on to produce things like Docker, and there are a plethora of different tools that have different applicabilities throughout programming as a discipline, but there are only so many principles. And the purpose of this course has been to introduce you to the principles. These are the things that are possible. It's your job now to find the tools that you need for whatever programming language and whatever project you're working on. Thank you very much. It's been a wonderful semester, and who knows? Maybe we'll see each other again sometime. I don't know. Possibly. But if not, enjoy the rest of your degree programs. Don't forget, take everything with a certain amount of humor. Humor helps grease the wheels. Yeah. Have a nice life. Take her easy, folks.